Welcome back to another episode of Geometry Regents Prep. So if you're someone who's going to be taking the August Regents because maybe you missed the June Regents or it didn't go the way that you liked, this is a good opportunity to start. I'm going to start off with a series of just going over similarity and congruence of polygons, and then from there we'll get into some trig, circles, and some proofs. So today we're going to go over Side-Splitter Theorem. I have it slightly in another video, but we're going to go a little bit more in depth. So you first started learning something similar to this when you're in 7th grade with learning constant proportionality, aka COP, if you recall that information. We're just going to start off with like a basic level of it and trying to figure out which sides correspond. And then from there, we can determine what the scale factor would be to get us from one of our triangles onto the other. So we look at this do now. So basically our warm up, we need to find the measure of side XY. So we're finding this green side over here. If we notice, we have two triangles that are similar to each other, and the best way for us to figure out which sides correspond is by looking at our similarity statement here. The order matters in the way that the letters are given. So A is first, B is second, C is third. X is first, Y is second, and Z is third. So here, this tells us what the order has to be and which parts have to correspond. So A, since it's 1, has to correspond with the side that's 1 on X, Y, Z, which will be X. B will correspond with Y, C will correspond with Z. BC corresponds with YZ, and then CA corresponds with ZX. So as long as you stay in the same order, it makes it easier for you to understand which sides should be mapped onto another one once a dilation fully occurs. So we know that XY is going to be our green. We also know that XY should correspond with AB because those are the first two. So we know that 4 corresponds with our missing side. Since this is the side that we're solving for, I'm going to put X because it's an unknown side, so we put an unknown variable. We also know that AC corresponds with XZ. Some of you have learned this in the past with a formula. Some of you may have learned it with like a ratio table, some sort of table or a diagram. But we're going to set this up as a proportion only because it's going to help us later on. But you could also just multiply from one triangle onto the other. So the proportion I'm going to set up is I'm going to put my blue over blue, green over green. But I'm going to start with the smaller blue and then put the larger blue. So we're going to start with AC, so small blue, over the large blue, XZ. And then since it's a proportion, we need to set both fractions equal to each other. So we're going to go back to our small again, but for the green this time. So AB over its corresponding part for the larger one, XY. Now all we have to do is plug in our values. So AC is 3, XZ is 12, AB is 4, XY is X. Since we set it up as a proportion, now all we have to do is cross multiply, aka the butterfly method. So we're going to multiply these two together, and then we're going to multiply those two together. So first we're going to start with what's on the left, so 3 and X equals 12 and 4, so we're going to multiply those since it's cross multiplication. 3 times X simplifies to 3X equals 48. And then now we need to divide both sides by 3 so that we can isolate X on the left side. And then this will tell us what the value of X will be, which would be 16. So XY equals 16. Another way you could have done this is take our 3 and figure out what the scale factor is to get us to 12. 3 times 4 is 12, which means that we'll do the same thing with our greens and do 4 times 4 to get X, which would be our 16 once again. So this is our basic like middle school level question. We're going to raise it up a notch and get into our high school question. But one thing that we should know about Side-Splitter Theorem is it's always going to be two triangles. One triangle is inscribed inside of another, and it will always have a pair of parallel sides. So it's going to have a side that's parallel to one another, And then it has to intersect with the two sides. Every single time we have this, it's going to divide it proportionally. So proportionally means it's going to have the same scale factor. When we have the same scale factor, that also means that we have a proper dilation. Which also tells us that both triangles will be similar. So in this case, we have an example where we have a triangle inscribed of another. So our main triangle is triangle ABC. So I can draw that off on the side for us so we can see it better. So we have triangle ABC, but you're also going to notice that we have a line that splits it into our second triangle. And that line is line segment EF. EF is going to be part of our second triangle, which is going to be what I'm going to call our smaller triangle. So I'm going to split this into our second. And if we notice, the top part of that triangle is A, E, and then F. Some of you may think, oh, I'm just going to use this portion down here. But remember that when we have side-splitter theorem, we're always splitting into two triangles. For the blue that's highlighted, that's 4 sides. So that'll be a quadrilateral, not a triangle. Triangle needs 3 sides. From here, we can start labeling our diagram and noticing what the pattern is, which will help us find the scale factor, but also determine if the sides are proportional as we want. So we know that AE, so this length over here, is 3, so we'll label it over here as 3. AF is 4. And then EF isn't labeled, but we also know that EF should be parallel to CB because they don't intersect. Side-splitter theorem always needs two lines that are parallel. We also know that angle A, is congruent to angle A, which will help us later on when we're trying to figure out our theorems. So like side similarity, side angle similarity, or angle similarity. Next up, we need to label the sides of our bigger triangle. So we have AC. It doesn't tell us the length of AC, so we have to do a little bit of math here. AC is its entire length, and we know that AE is 3 and EC is 6. So we're going to add those two together to find the length of AC. So 3 and 6 gets us 9. And we're going to do the same thing on the other side to find the length of AB. So we're going to take the length of AF and add it with the length of FB, so 8 plus 4, and we get 12 for the length of line segment AB. From here, we can set up our proportion, or you can just determine your scale factor. But I'm going to do the proportion just to make it simpler. So we have our corresponding sides, so AC is going to correspond with AE, and then AB is going to correspond with AF. So knowing this information, all we have to do is set it up into our fractions. So I'm going to do the large over small, large over small. So blue over blue, green over green. So AC over AE. If you wanted to, you could do AE over AC. You could also do AC over AB equals AE over AF. Completely up to you as long as the sides stay corresponding. And then we're going to set this equal to AB over AF. AC equals 9, AE is 3, AB is 12, and AF is 4. So we're going to cross multiply. If we get the same value for both sides, then we know that we found a proportional relationship. So 9 times 4 is 36, and then 12 times 3 is also 36. So this works. And then our scale factor to get from our large triangle to our small triangle is going to be 1/3. Some of you may think it's 3, but we're going from large to small. So it's going to be a reduction. So it needs to be a number that's less than 1, which means we're dealing with a fraction. Same thing here, 12 times 1/3, which is the same thing as 12 divided by 3, will get us to 4. So our scale factor for this problem, so K equals 1/3. Or if you wanted to go from small to large, K could equal 3. moving on. Now we have some Regents problems that we're going to use as practice. So we have triangle KLM where line segment NO is drawn such that angle KNO is congruent to angle KLM, and line segment NO is parallel to line segment LM. If KN equals 7, KL equals 6, and OM is 24, what is the length of line segment KO? So I'm going to start off with labeling my diagram, the information that we're given up top, and then we're going to label our numbers that's given us at the bottom. So we know that KNO, which means that we need to focus on the middle letter, is congruent to KLM. So KNO, KLM are both our congruent angles. And then NO is parallel to LM, which is already given to us. We also know that both triangles should share an angle, which is going to be angle K, which I'll show you in a second. KN is 7, NL is 6, OM is 24, and then we want to find the length of KO, so we're going to put X there. Now we're going to separate this into two triangles. We're going to have our small triangle, and then we're going to have our larger triangle. And then from there we can set up our proportion and determine what the length of KO is. So let's label our small one. So we have K at the top, O on the right, and on the bottom left. Large one, K at the top, M on the bottom right, L on the bottom left. We know that both triangles share angle K, so we're going to mark that one up so we know that those two are congruent. And then they both have angle N and L that are congruent to one another. So we could say that these two triangles are similar by angle, because that's enough information that's given to us off the rip. We can also go into the details to figure out if it could be side angle side or side side side. Actually, you can't use side 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 because we don't know the length of NO or LM. So we have 7 and X. And then for this one, we need to find the length of KL. So KL, we're going to take KN and add it with NL. So 7 plus 6, which is 13, will be the length of KL. We're going to do the same thing on the other side. So this is where some people get a little bit confused because we have that variable. If we add on one side, we're also going to have to add on the other. So we're just going to take the length of KO and add it to the length of OM. So this side we're going to label as X plus 24. Once we have that down, we can figure out our corresponding side. So KO corresponds with KM, and then KN corresponds with KL. So now all we have to do is set up our proportion, and then from there it can help us solve for the length of KO. So I'm going to do blue over blue, green over green again. So 7 over 13 equals X over X plus 24. From here, we need to cross multiply. Since we have two terms here, I'm just going to put in parentheses because I think it makes it easier for us to understand it. Okay, so we have 7 times X plus 24 equals 13 times X. When we have a set of parentheses like this, we know that we need to use the distributive property. So we're going to distribute the 7 to the X and then the 7 to the 24. So 7 times X is 7X, and then 7 times 24 is positive 168, equals 13 times X, so 13X. From here, we want to move our variable terms onto one side. So we know that 7X is on the left, but 13X is on the right. So we're going to move that 7X. And in order to do that, we have to do the inverse. We're going to subtract 7X from both sides. And once we do that, we're left with 168 equals 6X. From here, we need to get X by itself. So this is our basic step of dividing both sides by 6. So we're going to do 168 divided by 6 along with 6X divided by 6. Which gets us to 28 equals X. So now I'm going to go back and put equals 28 for each of them. And I'm just going to scribble this one out and make it 28. and simplify that, so that gives us 52. We're finding the length of KO, so we know that X is going to equal 28, so KO equals 28. You have to be very careful because sometimes it's easy and simple like this. Other times it'll ask you for the length of KM, or maybe even the length of OM if it wasn't given to you. If it asks for the length of KM, we know that we have to do 28 plus 24, and that will get us that 52. Next problem. I want you to take a moment and attempt to draw the diagram out yourself. So you're going to separate into two triangles, label your parts, whatever parts are parallel, label those, and then if you have any congruent angles, label those, and then we'll try in a moment. So if you need to pause the video, feel free and take a moment to do that. Next, we have two triangles. Our main triangles, triangle PQR, which is our larger triangle. So I'm going to draw that one first. And then we have our smaller triangle, which is triangle QST. I did not say that in the right order. Triangle STQ. So we have Q, PR, and then triangle STQ. We know that the length of QP needs to be the length of QS plus SP. So that will get us 7 once we add them. We don't know the length of QT, so I'm going to label that one as X until we can determine that. So we're going to do X plus 5 for the length of QR. QS we know is 5 because it's given to us. And then QT is going to be X, since that's the one side we don't know. We also know that PR and ST are going to be parallel and that they both share angle R. Since we have an angle in between two sides, at the end we should be able to prove this using side angle side similarity. With that said, now all we have to do is set up our proportion, solve for X, and then see what question that or what line segment we're solving for. In this case, we're solving for QR, so we want to make sure that we're doing whatever the value of X is plus 5. So we have 7 over 5. So I'm doing the large triangle over small, and then large triangle over small. Since we have two terms, once again, putting that in parentheses, over X. We're going to cross multiply this buddy. So we have 7 times X equals 5, and then in parentheses, X plus 5. 7 times X equals 7X, and then we're going to distribute the 5 to the X and the 5, so we get 5X plus 25. Once again, we want to make sure our variable terms are on one side and then our constants are on another. Constants are those numbers that don't have a variable. So we're going to move that 5x over to the side of 7x, and 7x is already by itself. And in order to do that, we're going to subtract 5x from both sides, meaning these two 5x's cancel out. So now we're left with 2x equals 25. From here, divide both sides by 2 to get x by itself, which tells us that x now equals 12.5. So we're going to go back in and replace x with 12.5 for each of them. I'm just going to scribble that out. So this side, 12.5 plus 5 is going to give us 17.5. And we know that we're solving for the length of QR. So since we're solving for QR, we want to make sure we know this length here, which will get us at 17.5 after we substitute x in. So QR equals 17.5. Be careful when you're doing this because some people will think, oh, I solved for x, so I'm done. So the length is going to be 12.5. No. Always go back, reread the problem, because sometimes the Regents does try to trick you. It's sometimes going to be a multiple choice question. In case I believe these are all multiple choice, I just made them open response. Or it'll be an open response question. I know for the June of 2026 test, it was an open response question. And it was a 2-point question, if I remember correctly. So just making sure you're going back and answering the question as it's asking can get you those valuable points that you need. If not, you can still get partial credit as long as your work is correct, even if you solve for the wrong side. Next up, we have practice problem number 1. So take a moment to pause the video. I want you to draw your diagrams on your own, label the sides, and see if you can determine what the length of AC is. Okay, I'm going to start going over it. You should have had some time to do this on your own if you paused. If you don't feel comfortable yet, just follow along. I'm going to start by just splitting this up into 2 triangles, so our small and our large one. Sorry, my drawings look a little off. So we have our small triangle, which is triangle ADE, and then our large triangle, which is triangle ABC. We know that DE is parallel to BC, so we're going to draw those symbols to show that it's parallel. We also know that both triangles share angle A, so those 2 angles are going to be congruent. And then now we can get into the next part, which is that if AD is 12, DB is 8, EC is 10, what is the length of AC? We don't know the length of AE, so I'm going to put that as X. And now we can transfer it over to our actual diagram. So this is our small, this is our large. So we know AD is 12, AE, since we don't know, we're putting as X. AB will be 12 plus 8, so that will get us 20. And then AC will be X plus 10. Now we can set up our proportion. So I'm going to do, I'll switch it up this time. Let's do small triangle over small triangle and then large triangle over large triangle. So 12 over X equals 20 over X plus 10. You'll still get the same answer as long as the sides are proportional. So if you chose to do 12 over 20 equals X over X plus 10, you can do that as well. It's going to give us the same thing each time. So we're going to cross multiply. So we're going to do 12 times X plus 10 equals 20 times X. So distribute that 12 to everything in parentheses, which gets us 12X plus 120 equals 20X. We notice that the variable term is by itself on the right side, which means that we need to move that variable term that's on the left over to the right side of our equation. So subtract both sides by 12X. So that will cancel out the 12X on the left side, leaving us with 120 equals 8X. Now we need to divide both sides by 8 to get the value of X by itself. So now we know that 15 equals X. So I'm going to go back in and make sure that I label that in each part of my diagram where I have X labeled. And we know that we're solving for AC. So we're solving for this entire length of a large triangle. So we're going to have to do 15 plus 10, which will get us 25. So we know that line segment AC equals 25, and that will be your final answer. So congratulations if you got that correct. If you got it incorrect, just take a moment to look over the work and see if you made any errors or are there any misconceptions that have been made. You can also find the scale factor from 12 to 20 if you wanted to, and then do the same thing to get to the other side. It's your choice of how you want to play this. I know some teachers teach it differently. I think this is the most understanding way because you get to see the diagram for some people who are better with who are better diagram learners, rather than just having a method taught to you over and over or an equation taught to you. But completely up to you. It is a very flexible question as long as you know that side-splitter theorem has a pair of parallel sides and an angle that's typically congruent to one another. Moving on to the next one. So take a moment to pause the video. Give yourself a moment to solve this. When you're done, you can unpause and check and see if your work matches with my own. Okay, first thing we're going to do, I'm going to label this diagram, and then I'm going to split it up. I'm going out of order this time. So we know that CL is 3.5, LE is 7.5, EA is 9.5, and then we don't know AR. So I'm going to label that side as X. Then split us up into two triangles. This is going to be my small triangle. I'll put an S. And then this one's going to be our larger triangle. I'll put an L. So our small triangle is ELA. Our larger triangle is ECR. And we know that both the triangles have angle E, so those are going to be our congruent angles, which means you can say that these two triangles are similar from side angle side similarity. EL 7.5, EA is 9.5, EC is going to be 7.5 plus 3.5, which gives us 11, and then ER is 9.5 plus X. So once again, set it up as our proportion. I'm going to do it the original way I showed you. So 7.5 over 11 equals 9.5 over 9.5 plus X. From here, we're going to cross multiply. So 7.5 parentheses 9.5 plus X equals 9.5 times 11. So let me pull out my calculator, because sadly I cannot do this math in my head. So distribute the 7.5 to 9.5 and the X, which leaves us with 71.25 plus 7.5X equals 9.5 times 11. So that would be 104.5. In this case, it's slightly different because we only have one variable term, but we have two constants. So we want to move the constant on the left to the constant on the right, since the one on the right is already by itself. It's already isolated. So we're going to subtract both sides by 71.25. To cancel out the 71.25 on the left side. And that will leave us with 7.5x equals 33.25. From here, we're going to divide both sides by 7.5, which should get you x equals 4.43 repeated. When I see that there's a decimal that's being repeated or it's not ending, I automatically think, what does it want us to round to? And in this case, we need to round to the nearest tenth. So it'll change to x equals 4.4 since the 3 is not 5 or above. So once again, go back in. Let's change our x values. 4.4. Scribble this one out, 4.4. So we're going to do that plus 9.5. So the length of AR equals 4.4. And that should be your final answer. Okay. It's another practice problem. Do the last two. So take a moment to pause the video and see if you can solve this on your own, and come back when you're done. Check over your work with mine. Alright, so let's start with our triangles. We have triangle ADC with EB being parallel to DC. AE is 9, which is written for us. ED is 5, written for us. And AB is 9.2. And we want to find the length of AC. I notice that BC isn't labeled, so we're going to label that with X and then separate into two triangles. So we have our small triangle and our large triangle. Triangle AEB and triangle ADC. AE is 9, AB is 9.2. AD is going to be 9 plus 5, so that'll give us 14. And then AC will be 9.2 plus X. I'm going to set up our proportion. I'm going to do small over small and then large over large this time. So 9 over 9.2 equals 14 over 9.2 plus x. Since we have two terms, once again in parentheses, cross multiply. So we get 9, and then in parentheses 9.2 plus x equals 14 times 9.2. So we're going to distribute the 9 to everything in parentheses. So 9 times 9.2, and then 9 times x. So we get 82.8 plus 9x equals 14 times 9.2, which is 128.8. Once again, we only have one variable term, so we want to move our constants. We're going to move this 82.8 to the other side by subtracting both sides by 82.8, which will cancel that out and leave us with 9x equals 46. Divide both sides by 9. And you should have gotten a variable. So we have, not a variable, a decimal. 5 equals, or x equals 5.1 repeated. So once again, those alarm sounds should sound. So we need to figure out what we need to round to, which is the nearest tenth. And we're also solving for line segment AC. So we know that x equals 5.1 repeated. So now I'm just going to add that 5.1 repeated with 9.2 and then round at the end. So AC equals 14.3 after we round to the nearest tenth. And our last one that we're going to try. So take a moment, pause the video, and attempt it on your own and check back when you're done. So we know that DE is parallel to AB, and then all the sides are labeled for us, and then we need to solve for DE. So DE we're going to label as X. This one's slightly different, but same concept, because it's the left side and the bottom side of our triangles is labeled rather than the left and the right side. But once again, we're still using the same exact strategy. It's just labeled on a different side. So we have CDE, and then our larger triangle, which is CAB. Once again, we know that angle C is going to be congruent to angle C. We know that DE is parallel to AB. And let's label our sides. So CD is 15. AB is 40, DE is X, and then AC is going to be 9 plus 15, which will get us 24. Now we just need to set up our proportion. So we're going to do CD over CA equals DE over AB. So 15 over 24 equals X over 40. Cross multiply, 15 times 40 equals X times 24. 15 times 40 is 600 equals 24x. Now we need to divide both sides by 24 to isolate our variable. Which leaves us with 25 equals x. So the length of DE is 25. If you'd like to see more videos like this, please make sure you like, subscribe, and comment. If you have any questions and concerns or any videos that you're looking forward to seeing, anything that can prepare you for a future Regents, or even if you're in summer school or in class and you're having questions about anything a teacher went over and you want a second opinion, feel free to shoot me a comment and I will gladly respond. But that's all for today. So you guys learned how to do side-splitter theorem, also using previous knowledge from 7th grade with proportions and your scale factors. So like I said, if you have any questions, make sure to like, subscribe, and then comment, of course, so I can answer those questions for you. I'll see you in the next video.